Hi, everyone. I'm Don Rooney.
And I'm John Timpane.
Welcome to the musical Innertube, the podcast born out of a mistake.
We once meant to introduce a soothing musical interlude, but we said soothing musical Innertube, and the name stuck.
On this podcast, we talk to interesting people about their interesting lives, jobs, hobbies, and passions.
Difference makers who really make a difference.
Mat Kaplan is Senior Communications Advisor for the Planetary Society in Pasadena. He's the creator and former host of their radio program and podcast, Planetary Radio. He's also a communications instructor at Cal State University in Long Beach, and he's a longtime pal of us here at the Innertube. He's one of the many lunatics who helped John navigate KUCI radio at the University of California at Irvine back in the 70s. Now, for many years, Matt has participated in something called the Humans to Mars Summit in Washington, D.C. He moderates panels and co-anchors their live stream coverage. Explore Mars honored him for all that with its Mars Horizon Award in 2022. So congratulations, Matt. Yay
Really?
For you.
Thank you, guys. Thank you so much. You even got my new title right.
Yeah. Well, you know, it's written on your forehead, so it was kind of easy to remember.
We were going to say Gone with the Wind, but it didn't seem to fit. So,
But Matt, so congratulations to you. What the hell is the Explore Mars Summit? What is it exactly?
Well, Explore Mars is the organization behind it. It's run by a guy named Chris Carberry, who's been in this area for a long time. I think he spent some time with the Mars Society before he started this other nonprofit. And every year in May, so far, they have this big gathering of Martians in Washington, D.C. And it really is, it's quite an incredible gathering. I mean, it's like everybody who's anybody in the Mars community tends to go to this thing. And I don't even remember, we tried last year to remember how many of these I've done for them. And we couldn't. But I think this was my 9th or 10th. And I think there was one year we missed because of that little thing called COVID. But we have had a blast. It's been 3 days in the past. This time it was 2 days, which I think was an improvement. I moderated 5 panels. One of them was a surprise. I did these little stand-up interviews during the breaks, and I introduced the day, and then I throw it to Chris Carberry, the CEO, up on the stage. It is so much fun. It is just because I'm surrounded by space geeks, and so we all understand each other, and these are the people who are going to get us to the red planet, who are someday, who are currently involved in getting us back to the moon, putting boots on the moon again, as they like to say.
so let's talk about this because you've done it for many times. I'm wondering, over the span of all those times at this conference, has the tone changed? Are the things you're talking about, have they developed? I'm wondering where we are right now, not just in terms of technology, but in terms of thinking it's going to happen and
Yeah.
thinking what has changed there.
It's a great question because a lot has changed. And I'll start with the sort of cliche line, which is sometimes I'm stealing from conversations about, fusion power. People say that, we're going to put the first humans on Mars. It's only 20 years away. It's always 20 years away. It's
Right. Right.
And that is kind of the current thinking. When we started this, they were talking about by 2030. Then there were people coming out with bumper stickers that said, Mars in 2033, we can do this.
Right.
And now they're talking about later, maybe 2040. What this represents is what we have learned about how incredibly hard it is to get people across to another planet. Mars is something like 1,000 times farther away than the moon. Let me see about that. 250,000 miles to the moon. So 100 times that would be what? 2.5, 25 million. Yep, it's about 1,000 times farther away than the moon, give or take. About maybe 500 times. And, you're never more than 2 or 3 days away from the moon. If you're headed out there, you can whip around it and come right back. But as a very wise man once told me, What happens if you're on your 1-year journey to Mars and the toilet breaks? What happens is everybody dies because you need the toilet to recycle stuff, mostly water, to keep everybody alive because you can't bring enough water with you. And you might find some water when you get to Mars. There is water there, we know now. But it's not so much that we don't have the rockets. We do have the rockets to get people to Mars. It's two other major problems: keeping people alive over the 2-year journey there and back, and landing, which is surprisingly difficult. And people don't always realize this because they look at the rovers like Curiosity and Perseverance, and they think, oh, hey, we just crank it down, we lower it on a rope. No, it's a lot more difficult when you've got something as heavy as having people in it. So that has been a big trend at Humans to Mars and across the Mars community, realizing how difficult it's going to be. The other big thing that has happened is that we now have China saying, oh, yeah, we're going to send people to Mars. They don't exactly say when, maybe by 2040. So, and they are, well on their way to sending Chinese taikonauts to the moon. So a lot of people say, hey, do we have a new space race brewing? Well, some people say that it's already underway. But, those are the big things that have evolved. And we have made progress, in the 10 years or so that I've been going to H2M. We're much better at the technologies. Thank the International Space Station, because it's been a good test bed for this stuff. But from the guys that I talked to a guy who runs a company called Paragon, who is developing systems for recycling the water on the space station, and he hopes to Mars someday. He says, no, we're not there yet. It's not reliable enough. So, yeah, we got a lot to learn.
So when you talk about you and the other space geeks getting together, when we're talking space geeks, we're not necessarily talking about people with foil hats and that sort of thing. You're talking about genuine, actual scientific types who are physically working in their departments and in their agencies to get this done. Is that right?
Absolutely, yeah. Well represented. NASA is well represented there. There was a conversation with the NASA Associate Administrator. Last year, we had the administrator himself. All kinds of folks show up at this thing from NASA. I had quite a few of them on my panel, not just from NASA, from the European Space Agency, from the Japanese Space Agency. I had on two of my panels, I had reps from JAXA, which is the Japanese agency. We even had a guy there who's one of the people running the United Arab Emirates Space Agency, which is doing amazing stuff with its space program. They have an orbiter going around Mars right now, the Hope orbiter, and other plans to land on the moon and so on. And you now have something like, I think I heard 70 countries with space programs. 39 of them are part of what NASA calls the Artemis Accords. And there were representatives of many of those nations at Humans to Mars, all of us geeks, all of us, who feel it's important for a lot of reasons, at least 20, for us to put people back on the moon and get people to Mars.
It seems to me that going to Mars is not just pointing the rocket in the right direction and then shooting it off.
And how?
I think what you just talked about with this huge international cooperative effort, that's got the best chance because you can have a lot set up in place. You can send parts of your observatory that you're going to have on the ground. You can build it ahead of time and make it prefab and land it. You can have robots build it for you. There's a lot that you can do. You can park way stations between you and Mars so that you have enough stuff. You can, little gas stations you can stop off and
premium, please.
Yes,
get me some beef jerky while you're in there.
Oh man, someday.
One thing that I've read about is that we should think of it as a staged operation rather than just one big 4-year thing, which doesn't seem like anybody can do it. We've never built anything that can run for 4 years without stopping, which is sort of what we're thinking about. I mean, okay, we have solar sails, which seem to have some interest. We have, I do want to talk to you about fusion. We can do it, but it blows us up.
Yeah.
So far. But I think, I think materials science is going to solve that. But I'm thinking it's really not something that one country can do competitively. It's got to be what a bunch of countries do cooperatively. And I think it would be, all things considered, relatively easy over the course of a decade to sit down, plan what it's going to look like at the end of it, and then start sending it off, piece by piece. I don't know. You could talk about that.
Well, this is exactly what was the topic of one of my panels, the one where I had the fellow from the UAE and from the ESA, the European Space Agency, and NASA was represented there as well. And it's hard to find a mission nowadays, a robotic mission nowadays, that is not an international collaboration of some kind. And the bigger the mission, the more expensive, the more complex, the more likely it is to have many partners from around the world. And isn't that great? That's one of the reasons why exploring space is so great, because as our boss, Bill Nye, says, he's our CEO at the Planetary Society, space brings us together. It's true. It's true in Congress. There aren't very many issues that Congress faces that actually have, bicameral support. And space is one of them, for the most part, almost unanimous. And we see this around the world, and there is absolutely no way that anybody is going to get people to Mars or even the moon as a single nation. The International Space Station started out under Reagan as Space Station Freedom, like freedom fries. And it became the International Space Station because it would not have happened if it had not been international. And oh my God, we've got Russians up there right now living and working with Americans and other people from around the world. And, that's got to have some value in it, even if it's just symbolic.
How much is the moon playing a part in getting us out of here and to Mars? Because like you said earlier, moon's like a 2-day trip. But most of what we hear about now with the Artemis project and other projects is to get us to the moon and to get us situated in a place where we have an encampment on the moon. And is that all prelude to doing the same thing on Mars?
Such a good question. And I can tell you, this is another thing that has developed over the last decade. When I first went to H2M, maybe the biggest issue, the big elephant in the room, the big space elephant in the room was, why are we going to the moon? We should go directly to Mars. Why are we wasting time going to the moon? And now, with the exception of a few people like Bob Zubrin, who I'll be talking to for the Planetary Society book club at the end of this month, he still thinks, no, the moon is a distraction. Most people agree now that we have to go to the moon to learn how to do this successfully at Mars. We don't know how to generate enough electricity yet on the surface of a world, and the moon is going to help us learn how to do that. We don't know yet how to, at large scale, make enough oxygen or find enough water. And here's a big one. We don't know how to deal with the dust on either the moon or Mars. The dust on the moon and Mars are very different. They're only united in that they both want to kill you. The moon has dust that is like tiny microscopic and macroscopic razor blades, which almost ended the Apollo program all by itself. Wear and tear on the spacecraft and the spacesuits. Mars has poisonous stuff on top, poisonous dust. And you don't want to track that back into your little habitat if you can help it. So we have so much to learn, and that's why it's so important that we, take the 2.5 days it gets to the moon before we start taking the, 9 months to a year to get to Mars.
And I should think that if you're in a laboratory and for some reason you blow the laboratory up, well, you haven't blown up a city, right? It's on the moon. It's on the moon, right? I mean,
Yeah.
as long as everybody, I mean, as long as everybody gets out of the building before it blows up, okay, well, it didn't work, let's go home. But you can't really do that on Earth, can you? You can't really.
Yeah.
The openness of the moon makes it a pretty good place to practice things such as you're talking about, Matt, especially the things like, sure, I think we can learn how to generate enough electricity, but we need to build those machines. We need to have the experience of doing it. I think the know-how and probably even the science exists, but we ain't done it yet. And we have to stay on the moon for a year, and see what that's like.
Yep, sure.
And die and, just see what that's like.
God forbid, but it'll probably happen.
John Tim Payne's version of collateral damage.
Yes.
The moon has a lot more to teach us, too. The moon has a lot to teach us about Earth because its rocks you can't get rocks that old on Earth. They're all buried deep in the mantle. And the dark side of the moon, which is not the dark side, it's the far side because it gets just as much light as the side we get to see. The Chinese, with their Chang'e 6, just went into orbit around the moon, and they're going to put a lander on the far side of the moon and try and get a sample of that back to Earth. And there's so much more you can do. The far side of the moon, best place in the solar system to build a radio telescope, because it's blocked from all the crap that we radio people put out on Earth.
Yes.
And it's just, there are so many astronomers who would love to have a giant radio dish on the backside of the moon. And so I suspect that'll happen someday.
And I think it's the best place in the solar system to get a tan. Wouldn't you say? I think, right?
Yeah. It'd only take a few seconds, and you got to hold your breath.
Yes, of course.
And then if you want to exfoliate, that dust has got you covered. So,
yeah, if it covers you, you're exfoliated already. We'll be back to our podcast in just a moment, but first, here's a soothing musical interlude.
Mat Kaplan is Senior Communications Advisor and former host of the program Planetary Radio for the Planetary Society in Pasadena. Matt has more than 30 years as an instructor at Cal State University at Long Beach.
Matt is a very well-known public figure as a raconteur, blasé farceur, debonair blagueur, and pâté de foie gras. He is possibly the first plate of French food we've ever had on the musical Innertube.
And he is well known as a host and moderator at a range of public roundtables and conversations, especially those about science or space.
Check out the Planetary Society website at planetary.org. There, you'll find more on planetary radio. And check out Matt's website, planetary.org/Matt-Kaplan.
And now we return you to the musical Innertube, already in progress. Out of all of the people you talked to, Matt, at the conference this year, what things were unusual to you, or what were the breakthrough or the surprising items that came out of the many discussions that you had?
Boy, I got to think about that because there was a lot of innovative stuff being presented. It's always interesting to hear from the people who want to grow habitats on Mars using like mushrooms, mycelia. And that's a perennial favorite of NASA and at conferences like this. And, there are people who are actually growing habitats on Earth. On the other hand, there's this wonderful woman named Melody Asher, who's a vice president of a company called ICON. And she came and participated again. I had her on one of my panels. They have built 3D printers, which are as big as a house, because they use them to build houses. And they did this largely to prove that you could go to the moon or Mars and use the material on the moon and Mars to actually create 3D structures with this gigantic robotic machine. But what's come out of that is they are building residences, they're building homes for people in the third world here on Earth. They're building them in the United States for the homeless because, once you have this giant robot, you just dump crud into it and it basically builds out a wall layer by layer, almost like Lincoln Logs, except it's kind of squirting it out like toothpaste. And you'd have to see if you go to the Icon website. I'm not getting paid by them, not yet anyway. But they will show you some of the homes that they are building. And they actually built one. There are analog astronauts in a NASA project who are living in one of these right now for months and months and months to simulate a stay on Mars. And they built it with a system. I don't know if it was Icons, but they built it with one of these gigantic 3D printers. So that's always amazing. Then we had a guy, he'd actually talked about this before, a terrific guy named Hoppy. His real name is Humphrey, but he's been at JPL for 1 million years. Hoppy is pushing this mission that you'd have to do it in 2035 because that's when everything lines up properly. But you could go to Mars with humans and fly by it. And then for free, it's a twofer. You fly right back out to Venus, whip around Venus for a close-up look, drop some probes along the way, and come back to Earth. And you could all do it with existing technology as long as you keep the people alive. The life support is the challenge. And do it in 1.5 years, which is truly amazing. And, is that going to happen? I really don't know. It's a real big long shot, yeah. But what a cool thing for somebody to be talking about and saying, look, we can actually do this if we learn how to keep people alive that long.
It's like many other things in life. The more you do something, the better you get at it because it teaches you and you learn from it what are the challenges. And so although I said no silently when you were saying, will this ever happen? And I admit it, I then now have to say, no, actually, we're going to try to do it because probably we can.
Yeah, somebody's going to do it.
But one of the things that this all tells me, and the stuff that you were talking about too, Matt, is I remember back to the Apollo and the Gemini missions. They didn't just give us Tang as a breakfast drink, but they also forwarded development of computers and living spaces and different things that we now use for insulation and that sort of thing. And I see as people are trying to work out how to keep astronauts alive on this year-long trip to Mars, that sort of thing will also pay off in construction here at home, that sort of thing.
It already is in so many, you name the field, and it has benefited from what we have done to be able to explore space and do space science and send stuff out there. There is no question about it. And this is, NASA tries to share this stuff. They do their spin-off report every year, but it just doesn't get the attention it deserves. You like your cell phone? You've got it because of space. You have it because of space exploration. The GPS that's built into your cell phone wouldn't happen without those satellites up there. It goes on and on and on. People talk about the computer that Neil Armstrong and Buzz Aldrin and the other Apollo astronauts used to get down to the moon. It was so advanced for its time. And now you have far, far more power. People like to say on your phone. No, it's a lot more computing power in the thermostat hanging on your wall. And this is, God, it is just endless. It's another one of my 20 reasons why it makes sense to further space exploration.
Talk about fusion for just a minute. Obviously, some people are looking at, because we have had some signal advances in the last 3 years. We now know that it can be done. I think we can say that.
Yeah. You can even get more energy out of it than you have to put into it.
For the first time.
The thing.
Yeah. Which is what we were trying to do in the first place. We were trying to make an energy creation system that didn't devastate the planet, kill dinosaurs, burn things, but we were trying to use the very forces of the universe to produce energy where there hadn't been before. So you're quite right. I'm just wondering, were people talking about that this year? Have they talked about it in the past? we're down the road a ways from being able to use it right now. But if we ever do solve the problem of, okay, we can make it, but it blows us up, because plasma is this very, very difficult thing to handle.
Yeah.
I'm just wondering, what people are saying about fusion.
I'll tell you how it comes up, but I'd have to include fission. NASA, a lot of people don't know that we had a fairly advanced nuclear rocket engine in the 1960s, part of the NERVA program. It was stopped because people realized, maybe you don't want a nuclear reactor spewing stuff out of its rear end down here on Earth. And that was probably a good decision. But now NASA is getting ready very soon to test a new nuclear rocket in space where you can do this kind of stuff safely, as you pointed out. And the key there is that you'll get so much more energy, so much more impulse, specific impulse, coming out of that rocket. And it'll make it so much safer to go places like Mars because you'll get there so much sooner, or you'll be able to take a lot more stuff with you, or both. The way fusion comes up, and it's going to kill me because there is Franklin Chang Diaz, a retired astronaut, has a company in Texas, and I can't remember the name of the company. They've been working for years to develop, basically, it's a fusion rocket. And it's not like a fusion reactor where it, just spins around in a donut-shaped thing. It spews that plasma out its rear end, and that's kind of the ultimate, short of, bringing matter and antimatter together. A fusion rocket is pretty much the ultimate that we can think of to get around the solar system in a hurry. And this kind of stuff does come up because there are a lot of people working on these advanced propulsion systems. Because if you could help it, space wants to kill you. You don't want to spend more time out there than you have to. And if you can get to Mars in, let's say, 2 or 3 months instead of 9 or 10 months, you're going to make it a lot more likely that people are going to get there without getting fried by some solar flare.
Let's key on that one phrase that you just said. Space wants to kill you.
Oh, boy.
Why the hell are we going out there when all that is against us? I mean, when you go into space, even just to the space station, a few 100,000 miles up above the Earth.
Like 400 miles.
400 miles. There you go.
Less than that, yeah.
You have to be suited up. Yeah, you can't go out there without protection. Why are we doing this when everything is working against us for just staying alive for even a minute out there?
I'll tell you about a great book that looks at exactly this question. And it's by Zach and Kelly Weinersmith. It's called A City on Mars. And it has really made a lot of space geeks angry, not the thinking ones, because they say, here are a list of the challenges we face going into space, including that it wants to kill us. But they talk about governance. They talk about economics. They talk about can children be born and thrive in a low-gravity situation or a zero-gravity situation? We don't even know that humans can reproduce that way. And could those children born on Mars or the moon ever come back to Earth? The jury is out, man. There is no data or very little data on whether these kinds of things could work. And so you're right. The challenges are huge. And yet the Weinersmiths, who put together this very entertaining book, Zach Weinersmith, his cartoons are throughout the book. They are space geeks. They want to see it happen because the main reason they want to see it happen, because it's so exciting, because it's so thrilling, because it's so inspiring. And the amount of inspiration that it can provide, especially to young people, and the science that it encourages, and the things we will learn by getting stuff wrong, as John was saying, trial by error, the benefits, we can't imagine the benefits. As the brilliant and sensitive Donald Rumsfeld once said, it's those unknown unknowns. Or as was it Ben Franklin or somebody like that said, of what use is a newborn baby? We don't know yet. It's all potential. One of them might grow up to be George Washington. So that's why. And because we have a lot to learn, and because this is the kind of thing that we do anyway. We're always looking beyond the next hill. We want to walk over that crest.
It's also something, and I think we need that kind of expansive optimism. We need the promise of more, just as human beings. I mean, we have it every day. We are a productive world economy where stuff is being invented that didn't exist before. And I speak as a person who spends some of his time trying to write poetry. And to me, that happens in poetry, that people create things that weren't there before. And it's sort of weird to stare at the page and go, wow, where did that come from? Not because I did it, but because it's there. And even this podcast is an example of our productive side where we actually can make things that didn't exist before. Once we get out into space and master the means of doing so, that's going to change us. There's no doubt about it.
Definitely. I have no doubt at all. The potential is so much greater than just reaching the New World, as they called it, this continents of North and South America. It's just about endless.
And if we can do it, as you said previously, with everybody involved, with all of the different nations gathering together to do it, as opposed to when France and England and Spain were all fighting over territories back in those exploration days. If we can do it all together, then that is a leap and bound over where we are now.
Yeah,
definitely.
Right on, brother.
Yeah. Now there's a leap back to the 60s for you. Matt, thanks so much for talking to us again. You always take us through the most interesting mazes, because space is just one huge unknown up there. And it's nice to go with somebody who has been rubbing elbows with those who are actually trying to get up there. So thanks again. And we'll talk to you soon. And meanwhile, what's the next thing on the Mat Kaplan calendar?
The Planetary Society overall. Can I make a plug? We have this new member community, online member community. And, for years, I wanted to have a Planetary Society book club. And I didn't have the bandwidth, as they say nowadays. And now I do, because I've backed off from the radio show. So every month we have some fantastic author like Andy Weir of The Martian. And David Brin will be on, and all kinds of other fascinating people, nonfiction and fiction. And we get people involved in the conversation. We're going to start a new series called Planetary. I don't know if it's going to be Planetary Profiles or Planetary People, but we'll do that. In July, I'll be in Chicago at the Ravinia Festival, the music festival, for the first public performance of the Moon's Symphony by my friend Amanda Falkenberg, conducted by the great conductor Marin Alsop. And we're going to do some spacey stuff with some space planetary scientists around that event in July as part of the Ravinia Festival. So come on out, folks.
Yeah. And you can get all that at planetary.org?
Thank you, Don. Yes, planetary.org. That's the one. I'd get in trouble with Bill if I didn't get the website in.
But it's planetary.org, just to make sure we got that exactly right, correct?
Exactly right. So now you owe John and I $5.
So if Matt, just to make sure we have that, okay, if I sat down at this machine that I'm talking about right now, it happens to have a keyboard. And if I were to type out planetary, the word, then dot and .org and hit return, it would take me there.
It better.
But see, we got those computers from space. If we didn't go to space, we wouldn't have planetary.org.
Exactly.
It all comes together.
Yep.
Matt, thanks again. Good luck on all your stuff, and we'll check up with you in a little bit to see how it all went.
Thank you, guys. It has been great fun. It has been fun talking with you for only the last half century or so, and I always look forward to it.
And thank you for listening to the Musical Innertube.
Hey, let us know how we're doing. send us an email at musicalinnertube, all one word, @gmail.com.
Do you know someone with a great story to tell? Let us know. Send us an email or log in to our website, musicalinnertube.com, and click on the microphone in the lower right-hand corner to leave us a voicemail.
And while you're on our website, take a few minutes to listen to past episodes of the podcast. They're all there, along with pictures and biographies of our guests, blog posts, and lots more.
And as always, our thanks to virtual band Car Radio Dog for providing us with our theme music.